Welcome back for Algebra 2, Section 10-4 lesson. So we're not going to do a warm-up today. We're just going to get started on the lesson. What we're going to be doing is evaluating inverse trig functions today and using trig equations to solve some application problems. First of all, we're going to learn what inverse means. I don't know why it doesn't say inverse sine there, but inverse sine, inverse cosine, inverse tangent. This is not the same thing as reciprocal that we did before. So the sine of theta is equal to 1, I should do cosecant, sorry. Cosecant of theta is equal to 1 over the sine of theta. You can just take the sine and flip it over and you get cosecant. That's a reciprocal. Today, we're done with those for now. We're going to learn about inverses. Inverse means to undo. So back a little while ago, we were doing things like find the cosine of 60 degrees. Okay, so you look at your unit circle and you go to 60 degrees and you find the cosine and you tell me the answer is 1/2. Wonderful. Now we can go backwards. What if I want to know what angle has an answer of 1/2? We're going to give the answer as an angle now. So that's what this notation over here means. Cosine of the angle is some kind of answer. To undo it, you need to put the answer over here with the cosine, and the answer that comes out will be an angle. Be very careful what mode your calculator is in. If you want a degree answer, you're going to switch it to degree mode. If you want a radian answer, you can do it in radian mode. For this lesson, you're going to want your unit circle and your calculator handy. We're going to be going back and forth, and you're going to have to remember to switch modes when you're doing a different kind of thing, or you're going to get some strange looking answers. All right, so what I do in my head is I remember when I see this little -1, I'm looking for the angle who has a cosine of 1/2. So my answer will be an angle. That's one thing I keep in my head with those inverses. It is not the same as the reciprocal. It is not cosecant. It is not secant. It's not cotangent. It is the inverse. There is another name for it. It's called the arc sine or arc cosine or arc tangent. We'll just talk about that later, but it's the same thing. It's just another word for that same notation. All right, here's the problem. If I asked you cosine inverse of 1/2, I just told you one of the answers is 60 degrees or pi over 3. But however, if you look at this unit circle, there's actually 2 places that have a 1/2 in the cosine x position here. So there's actually 2 different answers. Even more, there's actually an infinite number of answers, because this angle right here, I can just keep going around the circle and adding 2 pi, add 2 pi, add 2 pi, and I will get more and more and more answers. So there's actually an infinite number of answers to this problem right here. Lots and lots and lots. It's going to be pi over 3 all the way around and around and around, or also 5 pi over 3 around and around and around. So let's take a look at what's going to happen. Let's do a different one. Find all the possible values of inverse cosine of square root of 3 over 2. So use your head or your unit circle. Where on the unit circle is the square root of 3 over 2 in the cosine position? There's 1, there's 2. All the rest of them have negatives. So there's only going to ever be 2 or 1 answer to these problems. But then we have to add some more to make it an infinite number of answers to these problems. There's only going to be 2 spots on the unit circle. So we said, I forgot to write down the angles. We're going to answer this in radians. So pi over 6 and 11 pi over 6 are what I'm going to write down. But that's only 2 answers, and I want to find all possible answers. So I'm going to keep going around the circle. So if I start at pi over 6 and I go around the circle, that's another 2 pi. So I could just add 2 pi to that answer. And I could do that over and over and over and over again. So instead of writing this over and over and over again, we're just going to put an n here, where n is an integer. I'm not going to write the notation, but anyway, this is all I need to see from you. You don't need to write the n as an integer. I'm going to assume that. If it was a decimal, we'd have problems. It has to be an integer. It can be positive or negative, because I can also go backwards around the circle and get the same thing. So all I need to do on these answers is add 2 pi n and I'm good. If it's in radians, this is the answer and we're done. If they ask me in degrees, we can answer the same question in degrees. In degrees, we would have 30 degrees and 330 degrees. So let's just write those down, 30 degrees and 330 degrees. And if I want to keep spinning around the circle, if I'm in degrees, how far is one trip around the circle? Well, it's 360. So I need to add 360 over and over and over and over and over again. So when you write it in degree notation, you just put plus 360n on the end of each of your answers. So here we have in radians, here's in degrees. If you're doing your homework, I really just need the radians for this part of the homework. All right, let's skip that unit circle and try another one. What are all the answers for the inverse tangent of 1? Where is tangent equal to 1? Well, let's see. How do you find tangent? Tangent is sine over cosine, which means it's the y divided by the x. So if I divide the y by the x, do I get 1? There I get 1. So if you did some of the problems from the last lesson, you may have noticed that you get 1 when you divide these two answers. So here's one spot where it equals 1. If I divide these, I get -1. That's not what I want. Negative divided by a negative, though, that's positive. So here's my other answer. I've got pi over 4 and 5 pi over 4. So let's write down our answer here. Pi over 4, 5 pi over 4. But don't forget to give all of them 2 pi n plus 2 pi n. There are all of my answers in radians. Also could be done in degrees, but we're going to keep going. Now, in order for this to be a function, I don't want to have more than one answer. So we have this infinite number of answers that can kind of be a problem in math. Sometimes when we ask something, we only want one output. So what we do to make this an actual function is we are going to restrict the domain for sine, cosine, and tangent. Each one kind of has their own little rule. For sine on the unit circle, we are going to stick to the right half. So if we get sine of 30 and sine of -30, we're going to get two different answers. We're going to have positives and negatives. So this will, anytime I get an answer, I'll be over here. If I did between 0 and 180 or something, then I would have two of the same answer, and that wouldn't be okay. So for the sine, you just need to know you're going to stay on the right side. For cosine, you're going to stay on the top half. And tangent, you're going to stay on the right side, same as sine. So tangent and sine, you're both on the right-hand side. Cosine, you're on the top half, because this is positive and this is negative for those quadrants there. Okay, so notation-wise, when they are looking for one answer only, they are going to use a capital letter here. So notice the capitals. That means I want only one answer on this side of the unit circle. This is the notation. So if I was talking about radians, this is at -pi/2 to pi/2. So that just is explaining that we're talking about this half of the circle. If I'm in degrees, this is from -90 to 90. What you need to know about that is if your answer is 330 degrees, you're not going to say 330, you're going to say -30. So make sure that your number that you say is between -90 and 90, or -pi/2 and pi/2. For cosine, it's from 0 to 180, or from 0 to pi in radians. And tangent is the same as sine, so from -90 to 90. So this page is just reminding you that when there's a lowercase, you're going to have lots and lots and lots of answers, an infinite number, by putting that plus 2 pi n on the end, or plus 360n. And if it's capital, there is only going to be one answer. So, I said this earlier, but there is a name for that when you have sine inverse. Another name for that is arc sine. The button on your calculator, though, is the inverse sine. So we're probably going to use that one more often. But if you ever see arc sine, it's the same thing. They're looking for the angle whose sine is whatever this number is. And I'm looking for an angle to be my answer. All right, here we go. So this one has a capital letter. Now I'm only looking for one answer where is the cosine equal to the negative square root of 3 over 2? Try to do this in your head. This is where you're trying to picture your unit circle. Where's the cosine? Square root of 3 over 2, but negative. So we're going to go to the unit circle and find negative square root of 3 over 2 in the cosine position. Notice you'll find it in two spots. For cosine, we want to stay on the top half. So which one of these answers do I want to give? 5 pi over 6. If I'm talking about radians, the answer is 5 pi over 6. But this question also asks for degrees. So just look back at your unit circle if you need to, or convert this degrees to radians, radians to degrees, and you get those two answers. So it is only one angle. So I only have one answer. It's just another name for the same angle. Okay, the next one here has a little trick to it. Actually, let me go back to that one real quick. The one we just did, if you wanted to, you could type in your calculator cosine inverse by hitting second and then cosine. It will give you this cosine inverse. We can type in negative square root of 3 over 2. If you're in degree mode, you'll get 150. And if you're in radian mode, you're going to get some decimal that is equivalent to 5 pi over 6. Okay, so you can type these in your calculator. They will give you the capital, the first answer that comes up in the correct domain, but your calculator is not going to capitalize this. That's some books do that, some books don't. So anyway, the capital letter is just kind of something to be careful of. And how to put in your calculator is what I wanted you to do before we did this one. So here we have sine inverse of 3 halves. So on the unit circle, where is 3 halves? There is no 3 halves. Square root of 3 over 2 is not 3 halves. 3 halves is 1.5. So where on the unit circle is there something like 1.5? There isn't. So let's take a look again at the unit circle. Sine values are the y values, right? Sine is y. So what are the max and min of sine? What's the biggest y value we have on this graph? The tallest it gets is 1. And the lowest it gets is negative 1. So what that means is that sine can only be between negative 1 and 1. So if I want to undo it, my input can only be between negative 1 and 1. It's not. So this is not possible. If you type this in your calculator, you will get an error. Okay, so be careful that the input for these inverse trig functions cannot be bigger than 1 for sine and cosine. Tangent can be, because if I divide a number by a fraction, I get a bigger number, right? So you can have a tangent that's bigger than 1. You just can't have sine and cosine. Let's do another one that we can answer. Where on the unit circle is the inverse sine of negative square root of 2 over 2? So let's go find negative square root of 2 over 2. There's one and there's one. Now for sine and tangent, we want to be on the right half. So I want to be over here. These are my answers, but not really, because remember it said I want to be between negative pi over 2 and pi over 2, or between negative 90 and 90. Well, this answer is not between negative 90 and 90. So what I need to do is rename this angle with its negative angle. So this would be negative 45 degrees or negative pi over 4. Same as this one, but just drop down negative. So my answer to this problem is negative pi over 4 or negative 45 degrees. All right. Another example. Where is the cosine 0? So find the inverse cosine of 0. Cosine is your x. So cosine has an x of 0 there and there on top and bottom. And for cosine, we stay on top. Answer, 90 degrees or pi over 2. Okay, let's use some inverse trig to solve some problems. So first of all, a painter needs to lean a 30-foot ladder against a wall. So we're going to have a wall with a ladder leaning against it. Safety guidelines recommend that the distance between the base of the ladder and the wall should be 1/4 of the length of the ladder. 1/4 of 30 is 7.5. So the bottom from the ladder to the wall is 7.5 to the nearest degree. So make sure your calculator's in degree mode because we're going to use that. What angle should the ladder make with the ground? So I have a picture here. We're looking for the angle between a 7.5 distance here and a 30 distance here. Notice this is not to scale. And we do have a right triangle because our wall is vertical. Now, how am I going to solve this problem? It's possible you might remember this from geometry, but I have opposite over here, adjacent, and hypotenuse. So go back to sine SOHCAHTOA. We have adjacent and hypotenuse, so we're going to use cosine of theta is 7.5 adjacent over 30 for the hypotenuse. That's my setup. In order to type that in my calculator, though, we have to do cosine inverse of, because I'm looking for the angle whose cosine is 7.5 over 30. And the answer to that is 75 point, oh, it said to the nearest angle. So I believe it's 76 degrees because it said to the nearest whole angle. So that's what we're looking for. It said in degrees, so we're done. Nothing else to worry about there. Let's do one more problem here. A group of hikers wants to form a walk from a lake to an unusual rock formation. So here's my lovely blue lake. We are going to go the formation is 1 mile to the east and 0.75 miles north. So we're going to walk east and north, and we could go that way, but what I want to know is how could I get there this way? What angle would I need to depart to get to the same rock formation without walking 1.7 miles? I could even figure out how far it is, but what I really want to know is what angle do I need here? So SOHCAHTOA again, this time I have opposite and adjacent, which is tangent of theta is 0.75 over 1, which is 0.75. So to type it in my calculator, I'm going to do the inverse tangent, 0.75, in degree mode because we want to know what that would be. And I moved my calculator, so just 1 second. You can go ahead and put it in your calculator. Tangent inverse of 0.75 is third to the nearest degree. So it would be 37 degrees. So I would want to go 37 degrees north of east. If you're going northeast, you might want to figure out a different way to name that angle, but right here is 37 degrees. All right, there's one more section of this lesson, and you're going to want those calculators handy. We're going to be in degree mode because this is in degrees. That's why I know that. If this was in radians, I would change to radian mode. So we want to solve this problem. It's the same as before. I'm going to do sine inverse of 0.4, but the problem is 0.4 is not one of the numbers on my unit circle. So I can't just look at my unit circle to find that answer. Instead, I'm going to use my calculator. So if you type in sine of 0.4, you get 20. Oh, make sure you're in degree mode. You get 23.6 degrees. So that's great because 23.6 degrees is between negative 90 and 90. So we're done. Now here's another question. Sine of theta is 0.4. That looks like the same question, except this time I want my answer to be between 90 and 270. So if you remember from the beginning of this lesson, when we do sine inverse, we might get more than one answer, usually two that are on the unit circle. Basically, we're looking for the other one. So on our unit circle, or just a unit circle, I got the sine of 0.4 was 23.6. I can't erase it. 23.6. I knew there was a 6 in it. 23.6 degrees. So let's just draw that. 23.6 degrees is here. 23.6 degrees. Where else am I going to have a positive y coordinate, because a positive sign of 0.4? Where else on the unit circle is that going to be? Well, I need to go up 0.4. Where else would I hit my circle? Right there. So over here in quadrant 2, I've got another point of something comma 0.4, and I want to know what angle this is. Well, I'm going to have the same reference angle. So this angle inside here is 23.6 degrees. What I want to do is name this actual angle starting at 0. How far would that be? The best way to do that would just be to subtract it from 180. So if I do 180 minus 23.6, I get 156.4 degrees. Now this answer is in between these. It's between 90 and 270. So basically, the first question asked me for this one that's over here on the right side, and the second question asked me for the one on the left side. All right, it's not always supplementary, so sometimes you have to be careful of that. Let's try another one, because I know those can be a little bit confusing. All right, use your calculator. Type tangent inverse of -2. What is that to the nearest tenth? Negative 63.4 degrees. So all I did was type it in. Is negative 63.4 degrees between negative 90 and 90? Yes, wonderful, that's done. However, the second question, if I type it in, that is not in between 90 and 180. So I'm going to draw it out again. Just a really quick sketch can help a lot with these problems. I know that the answer that I got was negative 63.4, so I'm going to draw that negative 63.4 degree angle. And this time I have tangent, right? So tangent is when I divide the two. And when you divide the two, your other tangent one, it's always going to be directly opposite in the circle. So the good thing about tangents is they're always straight across from each other. Because if I divide these two coordinates, one's positive, one's negative, these are going to be the same coordinates, negative and positive. So you get the same answer. So if this is 63.4, then this angle is 63.4. I'm just kind of thinking of reference angles here. But what I want to name is this angle. So I need to figure out what that would be. This time it is also supplementary. So you can just do 180 minus 63.4 degrees. And you get 116.6 degrees. Be very careful with these because they're not always supplementary. If you have cosine, let's just say you had cosine and the answer was negative 30. The other one that would have the same cosine would be positive 30. So that's not supplementary. That's just another picture or just the positive version of the same. So that's it for lesson 10.4. Let me know if you have questions.